Two students are working together to find the sum of 13 and 7/10 and 6 and 54 hundredths. Aaron says that they should line up the three digits of 6.54 with the three digits of 3.7, like we do with whole numbers, so like this. But Chris says that they should line up the decimal points. Which student is correct, and why does this make sense? Pause the video, take a minute and think about it, and then come on back. Okay, hopefully you've had time to think about this problem and figure out which student is correct and why it makes sense. The student that's correct is Chris. You need to line up the decimal points. The reason why we line up the decimal points is because we need to have the ones in the ones column and the tens in the tens column, the tenths in the tenths column, and the hundredths in the hundredths column. And the easy way to make sure that all of the digits are in the right columns are to line up the decimal points. We would add up the hundredths, so there's only 4 hundredths, and then add up the tenths, so 7 and 5 is 12 tenths, carry the 1. And then 6 and 3 and 1 is 10, so carry the 1. And then we have 2024, but our decimal point goes here. It's between the ones column and the tenths column. So all of the decimal points line up. Now, we could have done this with blocks. The smallest place value we have is the hundredths. And the hundredths would be the little cubes, the tenths would be the longs, the ones would be the flats, so we have ones, and then tens would be the large cube. So we would have one of the big cubes, and then 3 flats, and then 7 longs. So 1, 2, 3, 4, 5, 6, 7. So that's 13.7, and then we would add 6.54, or 6 and 54 hundredths. Well, the ones is the flats, so we would add 6 flats, 5 longs, so 1, 2, 3, 4, 5, and then 4 hundredths. Well, what is this equal to? So the 4 hundredths, we're not going to do anything with that. But here we have, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can swap out the 10 longs for another flat. And then how many flats do we have? 1, 2, 3, 4, 5, 7, 8, 9, 10. So I can swap out the 10 flats for a cube. And so our answer would be, these are 10, so 10, 20. We don't have any flats, so we don't have any ones. So 20, and then our decimal point, 2 tenths, and 4 hundredths. So 20.24. Let's take a look at this problem. It says, how do we multiply decimals? Well, I'm sure you were taught to write down the numbers and just totally ignore the decimal points. So 2 and 7 tenths times 3 and 18 hundredths. So ignoring the decimal points, we just multiply like normal. 8 times 7 is 56. 8 times 2 is 16, plus the 5 that we carried would be 21. And then 1 times 27 is 27. And then 3 times 7 is 21. 3 times 2 is 6, plus the 2 that we carried is 8. So we would get 6, 8, 2, 4, 5, 8. And then we count how many digits are to the right of the decimal point in the problem. So the 7 is 1 digit, the 1 is 2 digits, and the 8 is 3 digits. So 1, 2, 3. So we count over 1, 2, 3 places and put our decimal point. Why does that work? Well, we'll get to the why in a minute. But just to make sure that we could be right, we have 2.7, so that's pretty close to 3, a little bit less. And then 3.18, that's about 3, a little bit more. So 3 times 3 is 9. So our answer should be close to 9. And it is. 8.586. It's a little less than 9, but it's close to it. So our answer is reasonable. So why does this work? What we're doing here with the 2 7/10 is we can write 2 7/10 as a mixed number. And 3 1800 would be 3 1800 as a mixed number. And then if we turn them into improper fractions, we would get 10 times 2 is 20, plus 7 is 27/10, times 100 times 3 is 300, plus 18, so 318 over 100. And so when we multiply these fractions, so we're going to multiply straight across, and so we get 27 times 318, and that's what we did here because we were ignoring the decimal points. And then we would have to divide, so this would equal, what we get, 8586. And then we would have to divide by 10 times 100 is 1,000. And we know that when we divide by like 10, we move the decimal point over 1, or if we divide by 100, we move the decimal point over 2. It's however many zeros we have. That's how many places we would move the decimal point over. So we're dividing by 1,000, so we would move the decimal point over 3 places. So that's why it works, because if we change it into a mixed number and then an improper fraction, this tells us how many places we move the decimal place over. The next problem wants us to review a little bit about our dividing with the blocks. And so it says how many groups of 3 longs and 8 little cubes are in a flat, 4 longs and 7 little cubes. So 1, 2, 3, 4, 5, 6, 7. Okay, so we want to create groups of 3 flats and 8 little cubes. Well, I only have 7 little cubes here, so I'm going to swap out this long for 10 little cubes. So here was 7, 8. You just double check. 2, 4, 6, 8. Yes. So that's one group. So now we need to find another. So in order to create groups with 3 longs, I need to swap this out for 10 longs. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I can create another group of 3 longs, 2, 4, 6, 8 cubes. Okay, and then 3 longs. Oop, I need some little cubes, so I'm going to swap some out. And so this was 10, so if I take 2 away, that should be 8. So 2, 4, 6, 8. Okay, well, we have 3 longs left, but only 3 little cubes, so we can't quite make another group. So our answer would be 3 groups with a remainder of 33. Please take a look at the homework and let me know if you have any questions. Come to my virtual office hours, email me, text me, and let me know how I can help you. Have a good day.